Hello and welcome back. Now we have come to the last episode that's going to be dealing with the conceptual model. So what this episode is going to be about is we're going to take it from scratch and then we're going to create a full model based on these 9 steps. As you can see in the picture here, we got 10 steps, but data collection is not really part of this step in the conceptual model. It is considered to be a prerequisite for making the actual conceptual model itself. So we're going to go through all of the previous steps that we have taken, and we're going to bind it all together before we proceed in the course. Up until this point, we have spoken about data collection, requirements and transactions, entities, attributes, and keys. And in this last episode, we spoke of relationships and cardinality between entities. So, in this episode, we will talk about how to combine all of this to create a full conceptual model that you can show to your boss or your client in order to impress them, and to flesh out the actual database that they want you to create. Now this is where the blueprint of the house gets the okay from the financiers, and after this stage we will move on to how you take this blueprint into an actual working one, and from there how you can create your database from this blueprint. So let's start with the data collection that we have done. The scenario we got here is we have done interviews with three different departments within a car sales business. So the first one we got is with the sales representatives themselves, and they say that it's hard for them to keep track of which vehicles are for sale and which have been sold already. And so it's not uncommon for them to get customers that come and want to look at a car that they have advertised, but that car has already been sold. A further thing that they have told us is that they find it hard to keep track of which customers the other sales reps are having, and so it's hard for them to see how well they are performing, and when a sales rep is quitting, all those customers tend to disappear. They would like a database that can keep these customers on file. Now, when speaking to the mechanics, they say it's hard to know which vehicles have been serviced when they are brought in over the weekend when the mechanics are not at the work. And sometimes the sales rep who makes sales on the weekend do not put the cars in the right spots in the parking lot. And so some cars get sold without a service attached to them. When speaking with the boss, he said that he wanted to make sure that the business ran smoothly, and he also said he would like to get some statistics from the database to make informed business decisions. So, based on this, we are going to choose a few entities. If we go back to 9 steps that we're gonna follow, you see we have our data collection. We're gonna then move on to choosing entities. So when choosing entities, we want to make sure that they are important for the business, and we want to make sure that we do not duplicate any entities. So a preferable way to do this is to write up a big list of all of the nouns that you can find when you are doing an interview, and then compile them together and see which entities makes most sense to you. For the purpose of this, I've already gone ahead and I have chosen 5 entities. So we got a customer, we got a sale, we got an employee, we got a vehicle, and service. From the interview, these are the 5 entities that I have chosen. So I plot them out on a piece of paper or in my conceptual model program. Now, what we do after this, we're gonna create relationships between them to see how they fit together, and this is gonna look a little bit something like this. So we got customers connected to sale, employees connected to sale, vehicles connected to sales, employees connected to service, and service connected to vehicles. Now we want to describe these relationships to make sure that we can talk about them with the customer. So we got the fact that a sale involves a customer and a customer can be involved in several sales. A vehicle can be involved in several sales over its lifetime, but a sale can only include one vehicle. Service can be done on several cars, and a car can have multiple services. A sale includes an employee, and an employee can be included in several sales. And a service is done by one employee, and an employee can do several services. There are our relationships and our restrictions on these relationships. So moving forward, we're going to place out our cardinality. Like if you remember from the previous episode, that means that we're going to decide how, based on these descriptions, how many instances we want to place on each entity. So, as you can see up at the customer in the far left corner, we got a customer can have one or many sales, since it is redundant to create a customer if they're not going to have any sales attached to them. So, likewise, a sale is going to be attached to one and only one customer. We're not going to allow them to do purchases together, so they're going to have to be one customer per purchase. The same goes for employees. Employees, though, they can have zero or many sales. So maybe it's a mechanic and they don't have any sales. But a sale must always include one and only one employee, because we want to keep track for maybe commission reasons. A vehicle can be included in zero or many sales, in case it were to be that we got a vehicle in, sold it, and then got it back and sold it again. So a sale, though, can only include one and only one vehicle. Now, as you can see, between service and vehicle, we have two zero or many cardinalities. Now, we're going to touch on this in episodes in the future where we're going to divide this, but that comes at the logical model phase, and so we're just going to leave it in for now, since this is a rough draft to talk with the business about what we're going to do. So after we have lined all of this up, we are going to want to check if all of the entities that we have, that we want to keep them. Maybe we had an employee and a mechanic, or a sales rep and a mechanic, and they sort of kept the same information. Then we would have to put them together into one entity that we would name employee, which we've already done here. But for the sake of argument, let's say we had one mechanic and one sales rep. Then this is the place where we will go, oh wait, they basically store the same information, and they're basically the same. It's just a difference in position, so we can put them together and then add a single attribute that tells us which position that the employee has. Now we check over all of our relationships. If there is a relationship that has more information about it that we discovered when we were doing our description of the relationships, we might want to create an entity in between the relationship or in between the two entities that the relationship currently is between. Further than that, if everything seems okay, we are going to move forward, and moving forward means that we are going to place out our primary keys. Now we want to look for naturally occurring primary keys first. Sadly, or not sadly, but it seems more common today that we are using constructed primary keys. And what I mean by that is that we have a primary key that's selected by the system, rather than having a primary key that comes into the system. There are advantages and disadvantages with this. An advantage of having a naturally occurring key is that it's easier for us to remember as humans. So you might remember your registration number on your vehicle, but you're not going to remember if we have a vehicle ID that says your vehicle is the ID like 1021. you're not going to remember that, but you're going to remember your registration number. The same goes with, for instance, if you're a customer, you might remember your phone number or social security number, but you're not going to remember your customer ID. Now we walk around this by, you don't really want to store social security numbers if you can avoid it, which means that we have a construct primary key on customer, on employee, even though we could have a natural occurring key, and that is because of the fact that if that information should leak when we don't really have the need to store it in the first place, it would be that much worse for the customer. So we've chosen to do a construct primary key here simply because of security reasons. So we give a customer ID, but we also have them fill in information such as an email, a phone number, the first name and surname. So should a customer come to us and say, oh, I don't remember what I purchased last, can you check it for me? We can do searches on their phone number and email, other unique attributes that we can use which are not chosen as a primary key. The same goes for our employees. Maybe we don't want to keep sensitive information in a database that's going to handle vehicles and sales, and we have a separate database that handles the social security number for salary reasons or whatever it might be. Now, when you're choosing a primary key, you need to ensure that the key is unique and it identifies each entity occurrence. Now, like I've said before, choosing a phone number might be unique for the person at the time, but what if the person updates their phone number? Or what if a person updates their email? It's going to change, which means that the attribute that we have chosen is not unique. So that's why we choose a customer ID, which is something that we have control over within the database rather than allowing them to have something which is changeable. Now, a social security number would not be changeable, but it creates other problems, like I've said. A primary key should be as short as possible, as well as it should be numeric where it's possible, which is why we're creating these construct primary keys. The reason why we don't use it on vehicle, where we have a registration number which is not numeric in its nature, is because it's such a convenient primary key that's there that not gonna create any security issues, and using a registration number on vehicle falls very naturally because of the fifth rule when it comes to choosing primary keys, which is a primary key should be easy to handle from a user perspective. Now, after we've identified these primary keys, we can more cleanly communicate with the customer, because when we sit down with them and talk about how the model looks and what we're looking at, we can also show them how everything is related to one another, as well as what type of search criteria or queries we're going to be using. And we need to analyze the model now to try to assure the client that the model will work over time and not just for this moment in time. We run the model against all of the functional requirements that we were given during a data collection phase. So, for instance, they wanted to be able to service vehicles more efficiently. They wanted to be able to track sales and customers as they relate to employees. They wanted to look at vehicles. All of that is included in our database, which means that as far as our transactions or functional requirements go, we are good with this model. Now, after we've gone through all of these steps, we come to the point that we take it to the customer so that they can validate it and that they are happy with the way that we have chosen to develop this. Now, once a thumbs up have been given, it's important to keep track of documentation to all of the relationships, the entities chosen, all of the data collection, how we've chosen primary keys, description of primary keys, descriptions of the relations. And after all of this is done, there is only one thing left for me to say, and that's thank you for watching today. In the next episode, we're going to be looking at the logical model. Now, since the most of the work that we have done is this groundwork that we're doing in the conceptual model, the logical models is going to be less episodes. But that doesn't mean that they are less important. It just means that we've done most of the heavy lifting already. So thank you for watching, and I hope to see you in the next episode.